Greetings, everybody. Dave DeWalt here, the founder and CEO of NightDragon. And we're coming here today to talk about our NightVision series. If you're not familiar with NightVision, it's our kind of influence event where we talk about threats and risks and solutions and best practices happening across the security tech ecosystem. NightDragon is an investor and advisor in the security tech world with lots and lots of experience over many years running companies, investing, and operating in this security tech world. So today we're talking about our night vision event called the State of Autonomy. It's kind of the year of the A's, I think. I like to joke about, AI, agentic, autonomy, but I got some new words that we're going to filter in, like autodidactic. That's a cool word. We also got like autonomic, which will be new words for you to learn as well, and autotelic. So Morgan and Hannah can look those up while we're chatting here for a minute. But we have a wonderful fireside chat with our managing director, Morgan Kayak, as well as Hannah Huffman, our vice president, who's running a lot of our defense investments as well. So autonomy is changing everything, right? The transformation of autonomy across all 5 major domains of warfare is here and now. And our market report on the state of autonomy, written by Hannah and Morgan, can give you a lot of detail. We'll talk about it today, but what a transformation it is. AI and agentic and autonomy are really changing things, but it's also changing the players as well. A lot of the primes and the global primes, as we like to say, are changing and giving way to the neo primes, the new emerging primes that are out there. And we're seeing just incredible, sort of inertia around these next generation companies. So we have a couple of really cool, we'll have a fireside chat. We'll have a couple showcases around a company called Epirus and a company called Saronic, all leading the industries around autonomy. So let's jump into it and we'll get started. Morgan and Hannah, thank you so much for joining. Let's talk a little bit, Morgan, first, just about the macro of things, if you would. How I mentioned autonomy is changing everything. Give me your perspective of how it's changing defense and kind of the 5 major domains that we were talking about.
Yeah, absolutely. And thanks for having me. I think back on the last Night Vision event that I was able to participate in. I remember it was right around the time ChatGPT came out, maybe a few months after. And we were talking about the impact of AI on cyber in particular. It's just been amazing to see over the past 3 years since that fundamental product release from OpenAI, how the entire industry and market has just changed. And so, the dynamic within secure tech in particular is much more pronounced relative to other industries. When we look at defense, AI has caused the ability for many startups to begin to innovate and bring autonomy to various systems. It's been fascinating to see not only the pace of innovation within AI, but also the rapid adoption we've seen across the consumer, enterprise, and now even government sectors. And so you're seeing that as a major driver of autonomy within defense. I think the second dynamic you're seeing within defense in particular and national security is how AI has been used in the battlefield. We now have real world examples in Eastern Europe, in the Middle East, of how impactful AI technologies can be. The fact that you can create drones that cost hundreds of dollars to take down tanks and planes that cost tens of millions of dollars, that is something that the world has woken to, and I think certainly has created a demand for AI-based technologies across all nation states out there who's thinking about defense. And then the last component we're seeing around national security defense is that there's much more receptivity within the DoD in particular, more recently developing organizations like the DIU and other types of contracting processes that enable commercial organizations to sell to the government. So with that new type of structure, process, and pathway in mind, we've seen commercial companies, startups rise to that innovation to meet that demand that's out there using innovative technologies we've seen more recently developed in consumer and enterprise, and then bringing those technologies into the hands of the warfighter. So it's just amazing to see. And Dave, to your point on the 5 domains, we're seeing it across maritime, across aerial, across ground and cyber. And Hannah will talk a little bit more about those specific domains and what we're seeing within each of them. But the fact that AI has come, it's just been an amazing boon to startups in the ecosystem to really innovate and enable our warfighters to have the latest technologies.
Yeah, Morgan, well said. And I've always called it for those who have followed me at all, but called it the perfect storm for many years, almost 2 decades, and it's true today. Like we watch the threats and risks and the geopolitical tensions, the vulnerabilities that have been created by all this inertia of technology, and now AI and autonomy disrupting that in a way. But I have a lot of optimism, Morgan, because I feel like AI and agentic capabilities, autonomy, can really level the playing field of defense as it relates to how big the gap was to offense, especially in cyber and AI areas as well. But to your point, let's jump into some categories and areas and help us define some of that, Hannah, for us, if you would, especially from the report's perspective. So walk us through it a little bit, if you would.
Yeah. So to level set, what do we as NightDragon define as autonomy? And so we define autonomy as systems or machines that are able to operate independent of any human intervention and are able to carry out various mission sets. So some of the mission sets that we think through are typical ISR missions. Hey, let's go see what's around that hill, what's around that corner. So before we send troops or we send anything forward deployed, we understand what the environment looks like. We've also seen incredible things in Ukraine with targeted missions where they're using drones to go and carry out strikes against huge Russian military ships. And so those are some of the mission sets that we think through. And ideally, these machines or systems are able to work in GPS or comms denied environments, are able to rapidly gather data and send that back to the operators, and are able to go into areas that might be too difficult or too dangerous for human soldiers to get to. And so when we think about autonomy in that sense, in the subcategories that we think through, Morgan kind of alluded to it. We think about these different subsectors across these different domains. And so we think about autonomy in subsea, sea, air, and space domains. And then additionally, cyber as well. We've seen an incredible amount of innovation in the cyber domain around autonomous capabilities that enable both offensive and defensive capabilities. And so, in addition to those watching for autonomous systems in those subcategories, there's a couple of adjacent categories as well that we watch really closely. One is counter UAS, or more broadly, counter autonomy. We have this huge rise of attritable systems that we as the US military are trying to procure and deploy, but so are adversaries as well. And so, how do we think about the defense against those different autonomous systems? And so, we have a company that we've invested in called Epirus. And so, we look at closely at companies who are able to track, understand, and then eventually neutralize drone and autonomous threats. And then another category that we find very interesting in this area as well is command and control. We know that the DoD has had this huge vision of joint domain command and control for almost 10 years now. And it's still just a concept. It's such a difficult problem to have a decentralized command and control, ideally across all of those different domains I just mentioned and all the attritable systems that we'll see executing in the field. How do we bring all of that together? How do we bring together all of that data, all of that intelligence, and be able to understand and then ultimately act in a rapid fashion, given how quickly things can change in theater? And so those are some of the categories that we've been watching really closely that can help broadly autonomy, counter autonomy, and then how do we think about enabling autonomy to continue to be powerful in the hands of the warfighter?
Well said, Hannah. And it's worth underscoring for a minute, I believe, and maybe there's a question towards you, Morgan. The national security implications here are profound, right? You just kind of alluded to it. Just the autonomy threat is enormous, and it comes from a variety of domains, almost all five major domains. You mentioned like the aerial threats of autonomy, but also in the world of cyber. Now we're seeing the potential self-healing, self-learning, autodidactic, autonomic capabilities that are coming with these solutions as well. But maybe Morgan, talk about it from a national security point of view, or at least your perspective on that, why this is so strategic right now in what we're seeing.
Yeah, I mean, so from a national security perspective, fundamentally, what autonomy does is give us the ability to save lives. Instead of putting human operators in those vehicles, in those ships, in those planes, we can put a robot instead. And I think the ability for these systems to work autonomously creates, something that's fundamental as saving lives. I think that creates a lot of interest in the technology itself. I think more broadly than that, though, one of the things we've seen is there's also a cost driver on autonomy. The ability to create autonomous systems at scale, to create hundreds and thousands of aerial drones, to create hundreds of USVs, autonomous surface vessels, I think the ability to do that creates a manufacturing edge when you think about defense, when you think about potential conflict in the future. And that's something that's creating a lot of demand out there. And so, the fact that autonomy helps save lives, but also helps you create attritable systems is something that gives you an edge to complete your mission. I think that's leading to a national imperative for a lot of national security organizations out there.
Yeah, I think this is really worth underscoring as well. I just did a speech the other day, and the realization of how many, just in the cyber digital domain, vulnerabilities or what's called CVEs, these are essentially vulnerability disclosures, occurred just so far in 2025. That number is very alarming, 19,972. So we're almost at 20,000 CVEs released by the US government alone through the US CERT on vulnerabilities in the network architecture and endpoint architectures that we all have. The ability to keep up with patching, prioritizing all these potential exploits from the vulnerabilities is nearly impossible without autonomy. So it gets very interesting as we start to see what autonomy can do to help prioritize vulnerabilities, patch those systems, self-heal those networks. That is a very, very positive thing. But maybe talk the other side of it, Hannah, for a second. What about threats and risks and challenges that we're seeing? What's keeping us up at night a little bit? Maybe scare us post Halloween here.
Yeah, so I think about challenges and risks for the companies that we look at here. There's kind of two different hurdles to go through. One, there's the technical hurdles that we're seeing. And then two is kind of the go to market execution. And so when we think about some of the challenges and risks that these companies face, I mean, we have this huge manufacturing problem. I remember when we were speaking with Saronic, when we learned what China's manufacturing capabilities was, it was eye opening in the worst way. Have already surpassed our naval fleet in size, 280 times our manufacturing capability. And so when we think about the gap between offense and defense here with one of our biggest near peer adversary, it is really concerning. And so one of the things that when we think about these companies that they must solve is this manufacturing at scale. If you build the product and the government wants it, but you're not able to provide the amount to the government, it is a huge problem. And oftentimes we see companies really focus on that technical part of the problem, but tend to miss on that manufacturing side of the problem. And so I think when some of the hurdles there, the manufacturing piece is enormous. And then I think the other thing that we're missing too is that we have this really awesome idea of this autonomous driven world. It's Ready Player One, Ender's Game, sci-fi, and that we expect that to just happen. But when we think about what happens on the edge and how much it needs to be processed on the decentralized edge, especially in these denied environments, you have to focus on those little details to be able to enable these systems to speak more broadly to each other. And so while post Halloween, the other side of this on the go to market side, what's even maybe more scarier is selling to the US government. And so, I think that right now it is the best time to be a commercial company selling to the US government. How much work we've done from Ecotel to DIU, being able to create pathways and procurement pathways for these companies is tremendous, but we're still in the early innings of where it needs to be. Procurement is still very difficult. The US government is still a very challenging customer to sell into. And so we need to continue this momentum of having these flexible procurement pathways for these companies. And so when I think about those challenges and risks, one is how do you do it from a technical and manufacturing side? But how do we also continue to be able to hurdle over these go-to-market hurdles that we see selling to the government, where you're beholden to a budget change by a program officer leaving? And so those are some of the things as we try to get this technology into the warfighter that potentially be tough challenges and risks to those companies.
Excellent segue, Hannah, and maybe over to Morgan and back to you as well about types of companies that look really interesting in this new era of autonomy, and what characteristics around those companies are you seeing that it's attracting the biggest investors? Because this is perhaps one of the biggest tailwinds we've seen in defense tech history, especially with the OB3 and the $1 trillion budget in DoD, NATO raising its war defense efforts in terms of budgets, and all over the world, the tensions that we have. So Morgan, like, what's the characteristics? What are you looking for as, running our investments here at NightDragon?
Yeah, yeah. I'll take that from a defense angle and also a cybersecurity angle. So on the defense side, because you are selling to the Defense Department and because you are providing a value, as I mentioned earlier, of fundamentally saving human lives, we think it's critical for these companies to own their own destiny. And what that means is that we want to see companies that are vertically integrated, that own the software, that own the hardware, that largely own the supply chain to an extent, but have the ability to take feedback from the warfighter and incorporate it into their process as quickly as possible. That kind of OODA loop type of feedback mechanism we think is critical, especially for companies that want to become that next neo prime out there to compete against those traditional defense industrial based companies. And so I think companies that do have an idea of how to incorporate and tightly integrate that entire hardware to software stack is important. Companies that do own their supply chain, that have large visibility into where their supply chain comes from and can control it is important. We've all seen the issues with supply chains more recently and how brittle they are. And then the final component, and we've kind of touched on this through the answers that both Hannah and I have given, but it's really the manufacturing ability of these teams. Like, do they have the ability to meet the need that and demand that the DoD and other governments have out there for these attritable systems, and can they solve this within a span of a year rather than 3 to 5 years? I think those are the types of things we look for in companies on defense. On the cyber side, I think ultimately what we want to do is find hard problems that are out there where there are a lot of noise. I mean, Dave, you alluded to the number of CVEs companies have to deal with. In the SOC, you're dealing with thousands of alerts that you have to manually triage day in and day out. Within the AI security space in general, AI is also creating a lot of noise with various AI technologies within the enterprise. And so we want to take the technology behind autonomy, the technology behind AI, and then apply it to these hard cybersecurity problems where you can cut through the noise, automate manual processes, augment existing cyber defenders, and enable them to defend against, the types of attacks we will eventually start seeing in the wild, where attackers will leverage their own AI, and you'll have this dynamic of AI versus AI out in the marketplace. And so, that's generally what we look for when we're looking at compelling technologies to invest in.
Love it, Morgan. Maybe Hannah, add to that, but also look out a little bit towards the future with your commentary. What are we seeing coming as well? You're looking at companies every single day, multiple a week. Both of you, Hannah, maybe give us a little add on and then what you're seeing going forward.
Yeah, I mean, a little bit of what the archetype is and what investors are being attracted to in this segment. I think a bad answer, but a true answer is everything. There are companies that are very hardware specific, software specific, hardware and software tightly coupled together, that if they're selling to the defense ecosystem right now are getting an insane amount of VC attention. I think this is the defense tech ecosystem more generally right now is seeing the most investment ever. And so now, because of the VC community has really stepped in to selling to defense, what does that look like coming over the years now that we are being able to fuel these platforms and these companies? And so I think in the next 5 years, what will be interesting is that we're already seeing program of records being built around these autonomous capabilities. And the DIU specifically has an entire arm dedicated to procuring autonomous systems into the hands of a warfighter. And so I think over 5 years, we're going to see this in theater, in production being used. And I think that more importantly, I think we're going to understand what's working and what's not. I think right now we're having so much excitement around this technology, but because it hasn't been deployed in production and hasn't been deployed in theater yet, we still don't quite know those limitations yet of, okay, what are we not so great at? And then what are we actually good at? And so I think we're actually going to continue to see waves of innovation in this sector as we start to have a stronger understanding of what is working and what's not. And I think when we think about the winners in these categories, we're going to see, this term has been coined, these neo primes. I think we're going to see these neo primes really stepping up next to the legacy defense industrial base. And of course, we had the Last Supper in the 90s where we went down to 5 primes. And I think that we're having this amazing movement towards, hey, let's have more competition and more platforms that are selling into the DoD. And most importantly, deterring conflict and protecting our soldiers out in the field. And so, again, we've hit on it a couple of times. When we think about the winners in this space, it is going to see who builds the technology to meet these certain problem sets, but also who has the go-to-market expertise from day one to go and sell into the DoD, to be able to go after these programs, not only win these contracts, but then rapidly expand into these program of records, which will make very attractive investments, but again, most importantly, delivering critical capabilities that we need.
Well said, Hannah. I always say it's the three T's: team, tech, and TAM. To your point, go to market or total addressable market, which also includes dual use in a lot of ways. I don't think either of you mentioned like not just selling defense, but also commercial applicability is very attractive for investors like us. Can they scale both defense and commercial is important from the total addressable market point of view. Morgan, wrap it up for us a little bit. What's your views on what's going for the future?
Yeah, I mean, so I think Hannah touched on where we see the defense market going with autonomy. I think within cyber, I think we're in early innings on the applicability of AI and autonomy within cyber. There's massive innovation going on at the early stage right now, and we're paying close attention to that. But we have yet to see a material impact of the use of AI in the attack landscape. I mean, the sad part of it is that you don't need AI to breach large organizations today. Because we still need to bolster our defenses around identity. We need to bolster our defenses around social engineering type attacks. But we will begin to start seeing, and we're seeing early signals in some of the threat reports from OpenAI and Anthropic. We're going to begin to see more AI-enabled attacks at scale, and that's fundamentally something that the cybersecurity industry and their customers need to be prepared against. And so I think that's one of the things that we're keeping an eye on is companies that are helping their customers face these new wave of attacks, these new types of threats in the future. It's interesting to be an investor in the middle of all of it.
Yeah, that's an understatement, Morgan. I always say, may we live in interesting times, which is both a blessing and a curse sometimes. And that's almost exactly how you would summarize the current state of things. It's a lot of things to look forward to positively, but a lot of scary things as well. Morgan, Hannah, thank you so much. What an honor to work with both of you. Thank you for all your incredible expertise in this field and all your hard work. I love working with you guys. Thank you so much for joining the Fireside Chat today.
Thanks,
Thanks,
Dave.
Dave.
Okay, we're going to move on to the showcases here in just a minute. And just want to again say thank you to our Fireside Chat hosts. And our next showcase will be Epirus, a very hot company that Hannah alluded to. And I want to introduce the company now. Thank you very much.
We have Epirus CTO Michael Hyatt joining us. Michael has over 20 years of experience in this market, and so I'm really looking forward to hearing your perspectives and having you share some of your wisdom. So thank you so much for joining.
Awesome. Thank you, Hannah. Appreciate the opportunity to join and share a little bit of what Epirus has been up to.
Awesome. Well, how about this? For those who may be not so familiar with Epirus, can you fill in the audience on what Epirus does and why the technology that you guys are building is so important for national security?
Sure. Epirus is, founded off the idea that, the traditional primes and, the defense industrial base was not reacting quickly enough to the market and to the threats that were coming out. We're only 6 years old, but we've really focused on how do we get in there and solve some of these hard problems that the world has, but aren't really being addressed. And so when we looked at what to focus on, we saw that the counter UAS problem was huge. It was sort of the same idea as the counter IED problem from like 2004, 2008, but now they're flying. And the classic sort of air defense models really didn't work and weren't addressing the problem very well. And so we looked at, how could we apply technology to do that? And we settled on this idea of using solid state technology that's very common in radars and EW systems, but use it to create, a high power microwave system that uses basically weaponized electromagnetic interference to take down these drones. And we've really focused on speed to market and how do we get the technology into the user's hands, and then making sure that when it's in the user's hands, that it's easy to operate, easy to maintain, it's very reliable. So it's actually ready to go out and solve some of these problems in the real world.
Yeah, and I think you hit on something interesting there regarding the speed to market. And we know that the defense industrial base has struggled with that over the last couple of years. And in particular, when we think about directed energy systems in particular, this is not a new problem set that's recently trying to be solved. We've been trying to do, whether it's high powered microwaves or lasers, trying to bring that to the warfighter, but there just has been some inherent challenges to that. But I think what attracted us to Epirus is that you guys have technically done something a little bit different and are able to bring something a little bit different to the warfighter. And so, can you talk a little bit about what sets Epirus's technology apart from traditional or legacy systems in the defense space?
Sure. It starts with a different philosophy where we don't wait for the government to tell us what to go build. We don't have a procurement spec to get started. And uh, we we really created the company with a sort of a three-legged stool of backgrounds. There's people like myself that came from that defense industrial base, and were sort of dissatisfied with the speed at which technology moved. And then we brought in also some of best in breed of folks from the commercial world, Silicon Valley, the automotive industry, the video game industry. And then also, hiring a heavy dose of veterans and people who have real world experience of using technology, and are able to give that feedback to us, quickly. I can basically go across, look down across the room and get feedback, as opposed to waiting, to try and get soldier touch points and things like that, or waiting for the government to document requirements. So we started with just setting ourselves up as a company to be able to operate much quicker. And then from there, also from a product philosophy perspective, we don't pursue the concept of performance above all else. Now, which is sort of the traditional way, and you look at how the laboratories go about design, looking for, how do we bring a directed energy system like a laser system to market? You basically have these really complicated machines that can only be serviced and done by PhDs in clean rooms with bunny suits on. And that's just not a way to build a weapon system that can be deployed widely, and it's not going to be developed at scale. And it's not. So we started with technology that we knew could scale, that we knew had high levels of manufacturability and reliability, so that we had essentially had that scale built in. And by marrying up the philosophy of not focusing on performance, but thinking about, well, how is someone going to maintain this? What are they going to do, in terms of even down to the details of, hey, it's really cold out. Someone's going to have gloves on. How are they going to operate the system? How are they going to be able to set up and in place the system? We try and think about the whole, sort of life cycle of it and the user stories of the users right in the beginning. And we mature that in, we build that in right from the get-go and in the initial architecture. And that allows, when a soldier touches it, they're like, I know how to use this. It's intuitive to use. It doesn't require weeks of training or anything like that. That allows us to get to market quicker. And that allows it to, when we get there and we show the performance, we're also ready to go scale, ready to go for fielding, and they're ready to basically develop doctrine around the system based on that.
Yeah, and I think that you hit on a lot of really amazing points, Vinit. I think really the takeaway is that you guys are just bringing a nice, unique, and fresh perspective to the market compared to what we have seen traditionally, and it seems to be really resonating with your guys' customer base. And as I think about fresh and new ideas, you guys talk about this idea of the sixth domain and the rise of autonomous warfare, which I think is just such an interesting concept. But can you define for the audience, what does the sixth domain mean, and how does that change how we need to protect our critical assets and infrastructure?
Yeah, absolutely. I think the concept of a sixth domain it's a whole new paradigm of warfare. When you talk about, air, land, sea, and space as the four physical domains, and then, they added cyber as a domain. And because it needed a whole new way of thinking. And in the classic domains, in the classic air defense, it's very much a one versus one engagements. when you look at cyber, you have these denial of service attacks coming from these big botnets, and you have hundreds of thousands of computers attacking your network. You need defenses that are made for one versus many. And what we're seeing with drones now is that it's now a one versus many engagement. Drones are basically cyber made physical, and you have these massive raids that you're seeing in Eastern Europe now, with the Russians sending in these just, bombardments of drones, and the ubiquity of the FPV drone now in the battle space. This is the sixth domain. And what makes it different is the classic problems of air defense are all still there. You have to deal with hypersonics. You have to deal with the cruise missiles. You have to deal with the manned aircraft and the bombers and the glide bombs. All that still exists. But now you have this new domain where the things that solve those other problems and address those other threats are no longer relevant. When you have, and we saw this with the Houthis in the Red Sea, just trying to basically deplete the various naval ships there. They're basically draining the magazines, and you can't use those same air defense tools against a sixth domain threat because it's specifically designed to counter those tools.
Yeah. And I think that really interesting points that you made. And I think you kind of painted this picture of this one-to-many problem and what we've seen emerge through autonomy. And of course, what we're seeing in Ukraine, the amount of havoc multiple drones can bring. And so the counter UAS problem just becomes all that more urgent. But it's a really challenging problem to solve. And autonomy just creates all of these different complicated layers and being able to solve that. And so from your perspective, what are some of the hardest technical challenges broadly in counter UAS? But also, how do you even bring autonomy to counter UAS itself, right? You have the, hey, let's defend against autonomy, but also how do you bring autonomy to counter UAS systems to make them faster, more agile, and able to respond to threats more quickly without human intervention?
Yeah, a lot to unpack there. To start, drones as a threat, they attack the entire kill chain from detect, track, and ID. Very difficult. The engage, which is where EPRIS is really focused on, is very difficult. And even doing battle damage assessment, very difficult with all of our traditional tools. And so counter UAS really needs to develop, in each stage of the kill chain, develop new technologies and new ways of employing old technologies to address it. When we look at, we're starting to see a lot of radars and stuff come out, and EIRs and all sorts of RF sniffers and things like that. And being able to merge all of that together in a holistic package, using broad sensor fusion and a lot of, AI ML tools are going to be what it takes to really handle the first part of the kill chain, the detect, track, ID. And then when you get to the engage, we definitely need a layered defense, because the threat is so dynamic and the threat is able to change so quickly, and the threat is frankly so varied across from group 1, group 2 drones all the way up to group 3 and UGVs, unmanned ground vehicles, and as well unmanned surface vessels, and even underwater vessels. All of that, again, attack the traditional kill chains that are out there. And the engagements will need to be able to handle all those different things. The tools used for engage need to be able to address that. And especially key is having one versus many effectors. If you're reliant on launching rockets and missiles at threats, the bad guys can count, and they know, how many interceptors you have in a box, and they can, get cameras and HUMINT and stuff like that and see, all right, an Iron Dome battery has X missiles. You see what Hezbollah did in 2017. Even back then, they just knew to shoot more rockets than they thought that the Israelis had interceptors. And that forces some really hard triage math on the Israelis, where they have to try and calculate where the rockets will drop and let some through and try and intercept the ones that are hitting population centers. That same math is not necessarily possible with drones because they can be course corrected. They can be, they aren't ballistic projectiles. And so you end up having to, if you just have kinetics, you end up with a massive magazine depth problem, and the bad guys will develop con-ops and tactics to deplete that magazine. So you need to have, that's where directed energy comes in, and this concept of infinite magazines, and the concept of, especially with high power microwave, is the ability to engage multiple targets simultaneously. We recently had a demonstration where we were able to put up 49 drones in a mixed swarm between Group 1 and Group 2 drones, and we were able to use our system to take out those drones, 49 drones, in less than 1 second. And we were able to run some other scenarios, and we were able to take out 61 of 61 drones in that day, and be able to put on a really good show for the folks who were able to attend. We think that that's a unique capability that, frankly, nobody else in the world can put out. That 49 hard kill drones in less than 1 second is a pretty awesome capability, and really shows how this weaponized electromagnetic interference can be a one-to-many type weapon system, as opposed to the traditional 1 versus 1 that would have taken a lot of missiles to take out those 49 drones.
I think you articulated that there are no shortage of problems to go solve. And it's amazing to see, again, even to the one-to-many, that Epirus is already starting to solve what was previously very challenging and thought impossible. And it's really exciting to see. And Epirus, you guys just recently raised a $250 million round, a round that NightDragon was very proud to participate in. And so how do you guys think about leveraging that new capital to capitalize on the momentum that you guys are seeing in the business? And where are you guys going to be deploying that capital and investing it across the business?
Yeah, I think, capital is really what allows us to move forward in the neoprime concept, where, we don't wait for the contracts to be let from the government of telling us, all right, I need X widgets, built to this specification. That capital allows us to scale ahead of need. That allows us to keep up with the speed of threat and stay relevant as the threat matures. And then that means that we can go out and, really aggressively pursue, the idea of helping the Army and the Air Force and the Navy, Marine Corps, and also our international partners, as well as domestic law enforcement, all tackle this threat. We can get out and show them how it works in real life. It's not just simulations. We're performing actual field tests, letting users play with it, getting out and doing events. All that, takes some capital and takes some time and resources. We also need to stay ahead of the threat. So we're continually investing in maturing the technologies that we need. And as we find gaps, whether it's other parts of the counter-UAS kill chain or similar threats, it allows us to, develop additional products to stay ahead of those needs as well.
Yeah, and I think what you just said ties into the next question well. So thinking about the future and looking ahead, how do you envision Epirus shaping the future of autonomous security over the next 5 to 10 years? Maybe what are some of the new innovations we should be keeping an eye out for?
Well, I think, as we talk about these, the 6 domain threats, one of the big, I guess, attributes of that is that it compresses the kill chains as well. Though there's a tremendous overload of information to an operator. And what we're going to see a lot of is a need for scalable autonomy. I don't think anyone, is ready for full Skynet, or anyone suggesting that, where we just let the robots take over. But we need to be able to distill the information for the operator and allow them to make the most efficient and most optimal decision based on that data that's available. And then once that decision is made, we need to be able to really effectively automate the execution of that. So decision aids and execution aids. We think that those will be really the foundation of a lot of the future systems that go out there. is,
Yeah.
how do we make an individual warfighter just that much more lethal? How do we make them that much more effective? How do we reduce collateral damage? How do we as we look towards law enforcement missions as opposed to Department of War missions, we see how do we keep the public safe? Drones there's so many good things that can happen with drones out there, from package delivery, from just fun aerial photography. There's lots of great uses of drones. We have lots of drone pilots here at Epirus. But how do we keep the airspace safe? In this indication, you see what's happening with airports in Europe right now, as people are maybe they have ill intent, but maybe not. But nobody knows, because just the airports are shut down is really what's happening, which is causing a lot of economic strife in Europe, and a lot of plane delays and everything like that, and closing the airports cause a lot of economic challenges.
Yeah.
So we really see things that helping in those areas, and doing so in a way that doesn't require a lot of training, doesn't require a lot of overload of the operator and special skills of the operator. We think that's the where the sweet spot is there.
Yeah. We're really looking forward to seeing all the things that you guys build to not only protect our troops abroad, but to your point, Michael, protecting us here domestically. And it's been amazing to see the progress the company has made, and we're excited to continue to partner with you and the entire Epirus team. So, Michael, thank you again for taking time out of your day and sharing some of your insights with us. And yeah, appreciate it.
Yeah, thank you very much.
What an exciting company Epirus is. I think you'll be hearing a lot more about Epirus, directed energy, electromagnetic pulsing, and the ability to have autonomy really meet the threat in the air and potentially in other domains as well, powered by Epirus. Thank you very much. Okay, next up is Saronic, another incredibly cool company really serving the autonomy platforms in the maritime space and really creating next generation resiliency and vertical integrations of supply chain like no other company has done before.
I've got none other than Saronic co-founder and chief technology officer, Viv Altakar. Viv, I'm not sure if there's anyone better in the defense ecosystem to talk about autonomy than you. For those who don't know, before Viv co-founded Saronic, he had a long career in engineering and bringing innovative technology to the Department of Defense, and was notably an early engineer at Anduril, helping build their autonomy software. So Viv, thanks so much for joining, and really looking forward to getting your perspective on this market.
Yeah, thanks. I appreciate it. And thanks for having me.
Yeah. So for those who may not know, I would love for you to maybe start by giving us just a quick overview of what Saronic does. And as we think about maritime autonomy, why is it so important of an imperative to national security?
Yeah, so Saronic, our mission is to redefine maritime superiority for the United States and its allies. And what that really means from a practical perspective is really rebuilding or kind of innovating on ocean infrastructure and ocean robotics that hasn't really been maybe prioritized or invested in for quite a long time. So we started off with autonomous surface vessels, and now we do all sorts of kind of ocean robots, from 6-foot ASVs all the way up to 150-foot plus ships. And we founded the company on the belief that one, like the maritime domain has been a little left behind in the autonomy kind of revolution over the last call it 12 to 15 years. We've probably spent 150 to $200 billion in self-driving cars. We've spent billions of dollars on autonomy in the air. A lot of that kind of investment and focus didn't really hit the maritime stack. For example, like a lot of acoustic technology is still fairly stagnant, and sort of applying kind of algorithms and approaches that are more common today on the vision side haven't really been applied there and have that same level of rigor. Similarly, when it comes to just understanding the ocean, we're pretty far behind. Like the famous adage is, we've explored more of space than we have of the bottom of the ocean floor. And so really what we're doing is focusing on getting that ocean infrastructure ready, building autonomous, robots in the ocean, by combining software, naval architecture, hardware, production capacity, all kind of in one house to really deliver value to both United States DoD and as well as commercial, international as well, and then commercial partners. The reason why it's important is because from what history tells us is that you know the Navy is largely the part of the armed forces that's responsible for deterring conflict. It's responsible for ensuring free global trade, which is what kind of the world today relies on. And so it's incredibly important for national security to make sure that we have the right infrastructure there. People are working and building systems that scale, ultimately to deliver value to both industry and the warfighter.
Yeah, and you mentioned it's amazing to see Saronic in particular, the rate of production and the development across the different systems and platforms that you guys had. Feels like you guys just started with Cutlass and Spyglass, and now you have this amazing vessel platforms across all of these different sizes. When we think about autonomy specifically, how is Saronic applying autonomy across those vessel platforms? From perception and navigation, but also to multi-vessel coordination now that we have this ability to maybe do some more swarm tactics across these different platforms. So can you talk a little bit about that?
Yeah, so I would say that autonomy largely, at least the way that we look at it in Saronic, is first and foremost starts off with infrastructure. So everybody likes to go and jump into, hey, I'm going to use this AI model, I'm going to use this algorithm. We actually started off focused on observability tooling and simulation. The market shifts or the rate of research applications on the AI model side are growing exponentially. There's new papers coming out, new algorithms coming out all the time. But it's important to make sure that when you're actually deploying them to a robot, the hardware software interface is really where a lot of the challenges are, but also where a lot of the alpha is. And so from our perspective, we started off with like, what is our electronic stack going to look like? What is the infrastructure going to look like around testing? So both software in the loop testing, hardware in the loop testing. What's our infrastructure going to look like for simulation? A lot of the early self-driving car companies, hadn't really focused on faster than real-time simulation, and so you'd end up in a scenario in which you do an 8-hour run in San Francisco, and it takes longer than 8 hours to replay all of the data and understand kind of what happened, and change algorithms and see what would have gone differently if I'd changed this parameter or this algorithm or whatever. So we started off with autonomy, really focused on the infrastructure side. The first boat that we actually had in the water was like a $600 Amazon boat, like a little plastic floating box that we then put like $10,000 worth of electronics in, and got it kind of driving around our local lake in Austin in like, I don't know, maybe 2 weeks. But that's obviously not sufficient to go and scale that up. And so what we're really doing is trying to understand what parts of the stack are we opinionated about. So we want to be opinionated about particular sensors, maybe a particular electronic stack or a network stack. Where do we want to actually be interoperable so that we can swap these things out as a function of what our customers need? For example, if you're extremely opinionated about your RF devices or your RF kind of electronics components, maybe not everybody is okay with that because people want to have different spectra or something like that. Maybe in another world, people are opinionated about cameras. And so you want to be flexible across camera domains. And that happens a little less, but it's still possible. And so we started off kind of with that frame of reference in mind. And once we had, and Spyglass was a great product to start off with because it was small, easy to test, easy to iterate on, not that expensive. And so we could start to kind of build up some competence around, is our infrastructure working? Our CI/CD pipelines, hardware in the loop testing, is that all something that we feel comfortable with? And then when you start to kind of increase in size, the problem surprisingly gets a little bit easier up to a certain point because you have less swap constraints. So your size, weight, and power problem is a little easier. You have a lot more power on these boats. And the nice part from working on drones and things like that in the past, you have so much power that you're actually kind of more of like a floating kind of compute box in the water. You can be this kind of gateway between the air-water interface where you can have acoustic devices for communication, you can have high-frequency RF devices for communication, and so going up in size class actually became kind of like easier from a packing problem or electronics problem, and then what the real crux for us was when we build a lot of boats and we manufacture at scale, we exponentially increase our ability to collect data. And so our data flywheel starts to move a lot faster to iterate on those autonomy algorithms, on those AI models. And ultimately, what we don't want to be in the game of is, hey, you spin up a new AI model, you think it works well on one boat, you push it out to the fleet. Guess what? It doesn't work on 30% of them. And so getting that infrastructure right up front is important, so that as you start scaling, you have confidence that, like, great, I'm going to roll this out to the fleet. I can go and test this. Like, there's a build of software that runs every night. It goes and tests against a bunch of different scenarios that then can go confirm to a developer or to an engineer, this is going to work. This works across all of these different scenarios, across all these different boats. Great. You can ship it out to the fleet. Otherwise, you're back to the drawing board. So I think that was really the important part for us in the early days.
Yeah, and I think you did a great job of hitting too on some of the technical challenges that you guys had to face, but you guys did them early on as you continued to architect the products from the beginning. And so as you continued to evolve the fleet, it was kind of nice. It was just more copy and pasting as you started to get to larger vessels, which is super interesting. One of the things that maybe we should hit on is a little bit of how do you think about human and machine teaming in the context of maritime autonomy? How do you think through when the human should be in the loop or on the loop versus, hey, this is when the autonomy just needs to take over and let the software do what the software does best? And so how do you think about the human machine teaming aspect in this market specifically?
Yeah, that's a great question. So again, this comes back to kind of the architectural decisions from Spyglass to Corsair to Mirage and Marauder. Echelon has been the C2 platform or kind of our user interface platform for interfacing with these systems. And so as we were going and developing autonomy features, one, as soon as we developed it for Spyglass, a large majority of it was easily extensible to the other platforms. As an example, your network management APIs or your waypoint APIs stay largely the same. But or maybe your track management or your kind of contact reports stay largely the same in terms of their API ontology. But the user interface continues to develop and adapt as you might have a different set of requirements or a different user experience when you use a small platform versus when you run a large ship in the ocean. You actually care just as much about what's happening outside the vessel as you do as what's happening inside. And so all of these user experience components become super critical. And from having worked on defense technology in the past, sometimes the systems that people, and especially in maritime too, the systems that people are used to they just frankly are not thought of as aesthetically pleasing user experience. They're kind of stagnant. They've been developed a long time ago. And so what we really wanted to do was kind of create this 5-star experience, or Brian Chesky from Airbnb has this story about how do you create a 7-star experience, where somebody leaves a 7-star review and it's out of 5. We really wanted to create this 7-star experience for what it takes to operate multiple platforms at the same time, which ends up kind of looking more like a video game, as you iterate. And then specifically on the large ship side, what does a 7-star experience look like for a ship captain who is no longer on the ship? And so, he or she might have to look at machinery control, the status of the drivetrains, fuel pumps, fuel transfer systems, seawater cleansing systems, like all of these different kind of subsystems inside the boat, just as much as, radar and camera performance outside. And so from a human machine teaming kind of perspective, the user experience can be very subjective. And so we try to collect as much feedback as possible and iterate and really try to go and build something that people would enjoy using. We even have a simulated version. And so you can kind of play in kind of a video game style fashion of just moving boats around and seeing things and whatnot. So I think the future here probably looks, over time, I think it's a function of comfort and the layer of abstraction between what a human feels like they need to do versus what they slowly grow accustomed to not needing to do manually. So as an example, if you have a level 2 ADAS system in your Ford, you're not going to, close your eyes or anything like that. You're going to be pretty focused on the road. You just don't need to press the accelerator anymore. Versus Tesla FSD, especially now, people are starting to get way, way, way more comfortable just hitting the 2 clicks and then, letting the car do its thing. And as that gets more mature, I think the user experience will change because people will stop feeling the need to intervene. So this is why one of our core metrics on the autonomy side is actually just manual interventions. How many times does a boat captain feel like they need to intervene? because that's the core user experience that we want to solve. Even if there's, some bits and pieces around the edge that aren't perfect, if the human who's using the system feels like, hey, I feel comfortable with this, I don't need to intervene, that's one of our North Stars. Because that's when even if the system is perfect, but the human constantly feels like, well, I don't know, like it doesn't look right. And, I'm constantly trying to like overtake and kind of manually maneuver things. Then we know we've either messed up, one, it's not autonomous, or two, we've messed up the user experience so people don't feel comfortable. So I think both of those things are important to get the human machine teaming piece right.
Yeah, and I think you bring up this great point that it's this gradual lessening of reliance on humans and more of the autonomy software. And especially as humans continue to get comfortable, as you said, playing the video game. And I think you painted this really interesting future of as this technology continues to evolve. And as we think about future conflicts, I think we're seeing this future emerge where it's increasingly autonomous and it's increasingly autonomous across multi-domains. You'll have your subsea autonomy, the sea autonomy, like where Saronic plays, land, air, and space. And so when you think about that autonomous multi-domain ecosystem, how do you see maritime autonomy fitting into that? And how does maritime autonomy continue to play off? As I think ideally what we would like is for all these different domains to be working together in a potential future conflict, or even in a situation to deter conflict. So can you talk a little bit about that?
Yeah. So, and let me caveat, when I say video game, I mean a lot of the design principles and network obfuscation and things like that to kind of make it seem like, things are still smooth, even though maybe the network quality is bad. I don't mean to be reductive about the technology, but there's a lot of principles that are taken from that. And so when I think about multi-domain kind of command and control, really what I look at is, how have we as humans in a society gone and like constructed the internet, right? The internet fundamentally is a completely distributed network of a bunch of different computers that come in all shapes and sizes, right? You have like, iPhones. I think, sometimes people's microwaves are connected to the internet, all the way to data center infrastructure, to fiber optics, to now, Starlink. So, the internet has kind of built this paradigm where if you get the open protocols right, and you have a bunch of people working on it over a long period of time, but you get the protocols right and you have the right way of going adapting infrastructure incrementally as technology gets better and better, you can build this network where kind of multi-domain, where like space computers are talking to computers on the ground, talking to small computers and big computers, and data is being routed through the ocean, and there's computers in the ocean as well. So I think about it from that perspective. And so when we bring it to kind of defense technology or robotics in general, I kind of think about it in a very similar way. Like, how do you go and make sure that the APIs are open, the network is optimized and easily understandable and easy to integrate with. And once if you look at it from a distributed system standpoint, if those two things are clear, then you can start to layer in all of the fancier stuff. So fusing data from your satellites to your ground assets, and subsea monitoring and getting that data from the bottom of the ocean to a surface platform like ours, and the surface platform going and pushing that data somewhere else. So to go and kind of live in that reality, I think we take a lot of inspiration from what we've done before on the internet side, and kind of adapt those same principles. And I actually think that the one piece that is going to be supercharged is how do you go and make sure that multi-domain systems are actually agreeing on what's going on from a situational awareness perspective. And I think kind of the exponential growth and proliferation of these more intelligent AI models will actually make that a lot easier in the future. I mean, in the past it was like throw Kalman filters at everything, and now it's getting quite good.
Yeah, and I think that actually thinking about that future, and actually that internet, by the way, that analogy I'm definitely going to have to steal. That's, I think, a great way to think about it. And I think, as you kind of mentioned of, hey, this is kind of the holy grail if we're able to do that. If you're thinking 5 to 10 years ahead, where do you see Saronic's technology and maritime autonomy as a whole heading? What do you think are some of the breakthroughs like you just mentioned, or maybe potential mission sets that will define the next era?
Yeah, I think so. I think 2006 was when the FAA allowed drones to have line of sight comms, and so the drone market really started to expand from a commercial perspective from 2006. And I think in 2022 or 2023 is when the FAA said we could use beyond line of sight comms for drones, and so you could start planning missions, like commercially planned missions, like from far away. Um, the like I would say on the maritime side, uh, what I would expect is for all of these things to have a compressed timeline, because technology is only growing faster and faster on the exponential curve, and so what I would expect is that in a much shorter time frame, we see kind of what happened in the UAV market, and then over time, I see what happened in the self-driving car market. The self-driving car market has a couple caveats, but I think the UAVs largely, from a software perspective and from a network perspective, have basically consolidated over a handful of technologies. Um, you know, GPS denied navigation is like there's like open source repos for GPS denied navigation now. You can build a drone at home with COTS products pretty quickly over a weekend. Self-driving cars a lot harder, but I think over time, what we should expect to see over the next 5 to 10 years is that that gets commoditized as well, and you have more cars come out that are just as capable, if we're doing our job as technologists correctly, right? To democratize the capability. I see the same thing happening in maritime, although it's just a harder initial hurdle, simply because maritime industry has just been around much longer, and so it's a lot more latent. I mean, if I think about it, like we invented cars. I mean, we invented the wheel in like 3500 BC. The first canoes were like 7000 BC. So like the boats kind of relatively kind of preceded the wheel by 3500 years. When we think about like cars really hitting mainstream production, that was like in the 1800s. Flight really took off 1906. Space was like 50s and 60s. But maritime has been around for a really, really long time. And it's still kind of the cornerstone of global trade. And so naturally, because a lot of the other stuff outside of the autonomy realm has consolidated, you have a very, very an industry that's not kind of interested in moving super quickly. Like they already have their mandate. Things seem like they're going well. Goods are shipped around the planet. 70% of GDP or something like that, of global GDP moves to the ocean. So the what I expect to see, with all those things in mind, what I expect to see is in the next, hopefully in a compressed timeline, maybe over the next 5 years, a lot of the technology gets a lot better very quickly and then starts to commoditize. Um, and really, I think in a world in which AI tools are exceptionally good at writing software and doing reasoning and kind of doing a lot of the mental labor, most of the alpha is restricted to that um, hardware software integration layer, where most of the IP or kind of alpha, whatever you want to call it, is between who's bridging the physical worlds and the digital worlds most effectively. And so when it comes to the maritime side, like whether it's exploring subsea, whether it's proliferation of surface assets, whether it's for DoD or commercial, whether it's autonomous shipping. So I think a lot of that will start to kind of coalesce on a shorter timeline. So we're standing on the shoulders of giants, right? Like the Waymos and Teslas of the world, the SpaceXs of the world, the Andurils of the world from a DoD perspective. Like we're and Palantirs. There's just like we learned a lot from what happened there, and we start hopefully do it faster this time.
So Vib, also maybe hit a little bit too on where do you see Saronic specifically in 5 to 10 years? Where do you see the company building and marching towards?
Yeah, I think it's been an extremely exciting and compressed 3 years. We've gone from, four, guys in a garage where in a city where there's water's not close by to almost 1,000 people across the United States, but still a lot of people in Austin. And so, we've delivered a lot of products and we've built a lot of technology, which I'm really, really excited about. So I think over the next 5 to 10 years, we'll continue to kind of press the gas, and really my intention is to we've gone fast, we need to accelerate, we need to move faster. I think from a company perspective, one of the initiatives that we have today is called Port Alpha, where we're looking to basically build the one of the largest shipyard in the world. Currently, globally, the United States doesn't rank very high in terms of shipbuilding capacity. And so what we intend to do is build one of the largest shipyards in the world to specifically aid in the development and build of autonomous boats, and potentially some manned ships as well. And so I think over the next 5 to 10 years, we'll stand that up and really start to revamp and change the narrative on shipbuilding throughput in the United States, which is going to be amazing. I think we've already made some very strong progress and inroads in our existing shipyard in Louisiana, where we're building Marauder. And that's been fantastic to see how quickly a group of dedicated people can move. Um, and so I expect to see a massive change in shipbuilding throughput, and hopefully we can push that forward. I think the other piece that kind of we hope to see is really be on the forefront of integrating technologies that I think the commercial world takes for granted, that just has a massive lag or latency as it gets to both kind of the DoD sector, but also the maritime sector. So today, ChatGPT has whatever, maybe a billion users, half a billion users. Kind of the core elements of that start to integrate those into the robotics realm, which is already happening in the research side. It's happening a lot in humanoids, but it hasn't really hit any of the other domains really. And so, kind of exploring what that looks like, and moving quickly and forward there. And then two, I think the interesting part about kind of ships is that these are large industrial assets, right? So these are fundamentally, you can think about them as like, cranes or like kind of, buildings. There's very large assets that most of the cost and the lifetime of the vehicle goes into maintenance and repair. And so one of the things that we hope to change over time is really the financial structure on like what are you actually paying for. And so if we not only build excellent autonomous boats, which I think have better specifications compared to human boats, or boats manned ships, just because you can remove the floating hotel and swap it out with a floating data center, it just leaves way more room for fuel and cargo and things like that. But also too, by reducing the complexity and iterating on kind of the electronics design and making sure like the vertical integration between hardware and software plays out to really optimize around maintenance and repair, we'll be in a position where these assets will be cheaper. They'll be cheaper to repair and maintain. You can proliferate them at much higher numbers, and ultimately make an extremely strong impact, not just on kind of defense applications, but also in the commercial world. When it comes to oil and gas and shipping and subsea survey, I think there's a lot of domains where reducing the cost on these systems will completely change what we'll be able to do in the future.
Yeah, I mean, a ton to look forward to. And Vib, thank you again for coming on and sharing your insights on this. We at NightDragon couldn't be more excited to partner with Saronic. And as you kind of illustrated that future, we have a ton of confidence that Saronic is going to be paving the way. So Vib, thank you again for coming on, and hope everyone enjoyed watching the showcase. Thanks again.
Thank you.
What an exciting company Saronic is, as I mentioned before, changing the world and the threats around the world in the maritime space. Autonomy can never be more innovative than what Saronic's doing. So thank you. As I mentioned, the art of the possible is happening now with AI and agentic and autonomy. So I just want to say thank you to everybody who participated here. Thank you to our company, Zephyrus Saronic. Thank you to our managing director, Maureen Kayak, as well as Hannah Huffman for being on the fireside chat as well. And thank you to the whole NightDragon team for helping to lead the State of Autonomy report, which is our second major report from State of Physical Security we did earlier in the year to State of Autonomy. We'll be doing more of these in 2026 as well. And just want to say thank you to all our investors, all of our partners, all of our employees as part of this. It takes a village, I always say. So I appreciate all the hard work and look forward to working with you all. Happy holidays, everybody.